Hi, my name's Phil. I work at Coffee Meets Bagel. I'm a DevOps engineer. I'm part of the infrastructure team of 2 there. I've been working with Cassandra for only like 5 months now, so this isn't going to be a talk where I get up and I tell you how to do things, because I'm pretty new to it myself. What it is more of a talk about how we've been using Cassandra, some of the things that we've run into, and some of the things we've learned, and kind of how we've gone about addressing those things. So, first of all, what is Coffee Meets Bagel? We are a mobile dating app. We don't have a web presence, but we're on iOS and Android. Our probably main thing that we do is we're focused on creating highly curated matches that you get every day at noon. So you might get 10, you might get 20, but those are going to come in at one specific time in the day. It's not going to be like some other apps where you maybe swipe a lot and have like 100 people you see. We have an amazing group of engineers. I don't know if that even belongs in this talk, but I'm just really proud of the people I work with. They're really great people, really smart team. And we use Cassandra as one of our primary data sources. We do use some others, but definitely we use Cassandra for a lot of things, as I'm getting ready to talk about. So, use case number 1. What's happening at noon? That's something we see on a lot of our t-shirts and things, but if you think about what I just said that we do, what happens at noon is we get giant, heavy traffic spikes, because all of these bagels or matches go out at noon, and everybody is looking at profiles, chatting, seeing what they got today, pretty much. Use case number 2 is what's happening the rest of the time, which is going to be our matching algorithms are going to be running and using our data stores and doing as much machine learning and matching that they can do in order to make sure that people get the best matches they can get. So our approach, as I mentioned, I'm not a long-time Cassandra user. In fact, the day that I started at Coffee Meets Bagel, I'd kind of had a vague idea of what Cassandra was, but I hadn't actually used it. And so one of the very first tasks that I was given by another engineer was to spin up a new Cassandra node, which luckily that went really well, because it was a well-documented process. Everything was good. But the funny thing was that he afterwards he said, "So don't worry," because I must have looked worried. But he's like, "Don't worry. In a month, we'll all be Cassandra experts, and we won't have to worry about this anymore." I was like, "Oh, okay, yeah." So 5 months later, that's not exactly happened just yet, but but we're learning, we're getting better, and we're still seeing a lot of growth. So like all the time, we're hitting new levels of traffic at the same time of trying to figure these things out. So our general approach, back to the slide, is to, when we hit one of these snags, we research, just like anybody. We theorize, and then we experiment a lot. And the reason that's in such big lettering there is just that it's really easy to limit. If there was any kind of moral at all to this story, which I don't know that there is, but if there was one, it would be to experiment a lot, because you can kind of sit back and you can say, well, this should work this way and this should work that way, and that kind of reasoning works, so long as that kind of reasoning works. And so the thing is, we found it best to not limit ourselves too much by that, basically, and to continue to experiment, try different things as you go along, and then repeat. So anyway, so one of the first things that I kind of hit up against is just the process of repairing our nodes. It seems really simple. The kind of naive approach is to just come in and just do a no tool repair on the command line. But at that point, our data was of a size, and our cluster was such a size that I'm not sure if those ever finished. They still might be running in the background somewhere on our Cassandra cluster. I really don't know. But it wasn't a good thing for us to be doing to try to repair the cluster. And the reason that's important is because we were having some issues, and we were kind of locked into the cluster as it was. We were afraid to kind of basically make changes to what we had because we weren't able to repair. And does that make sense? Like, we just didn't have that mobility to be able to test out new things. So one of the first things we did is address this repair issue. We wanted to run regular automated repairs. Basically, when we tried to run a repair, sometimes they would hang. Sometimes they would never return, even though I think they actually finished okay. And yeah, I kind of skipped around a little bit. So that was our first challenge. The things we looked at to address that would be to, well, at first we just manually did the no tool repair with the primary range argument on it on each of our nodes. So that works. There was nothing really wrong with it, except for it required our engineers to be up at midnight running no tool repair in a spreadsheet with all of our different nodes, and it just wasn't very good for the long term. We considered using Cassandra Reaper. We actually had some good experiences with Reaper. It was actually good for us when it worked, but the version of Java we were using at that time required some patching to the Reaper source, and we weren't really sure how well that was. I'm still not sure if a lot of people are still using Cassandra Reaper or not. So basically, just on the kind of complication level, we decided not to use Reaper. The last option there that we considered was DataStax's Ops Center. Some of the newer versions of Ops Center can do repairs. Maybe it's not even just the newer versions, but it might also be just if you have DSE, which is something we've been on the fence about a lot, about whether we want to move to DSE. Right now we're on open source Cassandra. We don't have anything against DSE. In fact, actually DataStax has helped us a lot. We're in the startup program, and they've really done a good job of consulting with us, helping us kind of work through some of these issues. But that was an option. And where we ended up was we just run a Python script. Basically, we found a Python script on GitHub. The link is up there in really small letters, Brian Gallu. What it does, we made a few alterations to it, but basically it splits your repairs into smaller sub-ranges and runs them independently. So it just gives you a more granular control on your repair commands. We run that out of Jenkins, and it triggers nightly. And basically, we repair about 1/7 of our cluster every day. And so the idea is that all ranges will get repaired over the course of a week. And so that's kind of what we're currently doing. So that was the easy stuff. That was the how do we repair our cluster. Number 2, going with the Odyssey kind of motif and the Cyclops. Memory management. The real problem we were having is we were having Java heap issues. Garbage collection became an issue at a certain point. We were seeing this sawtooth pattern when we looked at our memory management tools. We saw long GC pauses, like multiple seconds, where things were just very unresponsive. And so these things would basically, you can see in that graph in the background, that's actually a graph of a few of our servers during that time period. The Java heap would just kind of rise to a certain point, and then it would hit a spot, and our Cassandra cluster would have issues. Basically, that node would have to be restarted. So we went back to this experimentation approach. And this is also where we talked to DataStax, and we tried a bunch of things. We upgraded to Java 8. We started doing a no-tool flush. That one came out of nowhere. That was just one of our engineers that had been on call and said, I've noticed that when I want to get sleep at night, if I just go in and do a no-tool flush and flush all of our memory to disks on all the Cassandra, it's like I get some sleep that night. And so that's where that came from. And so we tried it, and it worked well for us. So we automated it, and it's kind of a bit of duct tape. If anybody has any, like I said, I'm not up here as an expert. If anybody knows what's going on with that can help, please talk to me when we get done here. we switched over to the G1 garbage collector. We started manually setting our heap sizes. We upgraded our Cassandra to 2.1.1.5, and we tried a whole bunch of other little tweaks. And you can actually see up there on the graph, that's actually over many months of time. And as you go all the way to the left, you can see this kind of chaos where these servers are going up and down. You can kind of see then where they kind of line up a little bit. Those were probably rolling restarts we were having at that time. And then you can see as we kind of started changing the configurations a little bit more, adding the manual flushes, flattens out, increased our heap size, raises up, and now it's at a much healthier spot. We don't have middle of the night calls that, hey, you have a Cassandra node down. So this is kind of an ongoing thing for us. We're still experimenting with a lot of different things. We actually have three distinct key spaces. I discussed two of the use cases earlier. And right now we're working on getting those separated out into different data centers so that we can actually tweak those machines to be specific to that particular use case. We're trying different instance types. We're constantly bringing up nodes of a new instance type, seeing how they perform, and then if they don't perform well, bringing them back down again. We're performing experimentation about whether we can use EBS drives or whether we can use instance stores on AWS. Everything we do is currently located on AWS. There's a lot of conflicting information about whether it's okay to run Cassandra on EBS, so we're just kind of testing the waters and seeing how it works out. We're trying different file systems, ext4 versus XFS file systems. All these things are just things that we've run across on the internet. It's worked for somebody, maybe it's not worked for somebody else, and we're just going to try it and see how it goes. So issues that still remain for us. Actually, we're getting decent performance and decent stability at this point out of our Cassandra cluster. The things that remain are, we're still running that node tool flush that I mentioned that was just kind of an anecdotal thing that worked out. Still, we don't know why that needs to be done. We do know that if it doesn't run, we do have issues. So it's going to keep going until we figure that one out. One of our data centers right now is running constant compactions on the disk. We don't really know why. And generally, we just want more automation. All of these things, it would be best if we could just push button, or even the dream would be auto-scaling. I don't know if that's a thing that Cassandra ever gets to the point of, but I would love to see us being able to auto-scale. And yeah, we're still working on it. So with every iteration, we learn more. Performance gets a little bit better. We get a little bit closer to that idea of, the big win, which is just this horizontally scalable platform where it just gets bigger and bigger, and we just don't have to worry about it too much. I don't know if that dream's really reality, but it seems to be getting a little bit closer. So, P.S. We're hiring. We're looking for backend engineers, backend engineering managers, senior data scientists, and lead test engineers. So if any of this sounds like interesting to you, or anybody Coffee Meets Bagel, we're hiring. So yeah, that's probably it. I don't know if I ran through that really fast or. Yeah. Does anybody have any questions? Go ahead, sir.
So I'm just, maybe you mentioned this before, but how much traffic is your Cassandra cluster getting, like reads and writes per whatever period?
The question is, how much traffic does our Cassandra cluster get as far as reads and writes? And off the top of my head, I don't actually know. I know our web app gets 15 to 20,000 requests a minute during peak times. But as far as throughput or number of requests, I don't have that information off the top of my head. Sure? Yeah.
I guess under what conditions would you using like Cassandra as opposed to MySQL or Elasticsearch or other?
Okay, the question is, under what circumstances are we using Cassandra versus other backends?
Yeah.
That's one that one of our developers should talk to you about. I'm totally an infrastructure guy. So I can tell you that we use Cassandra for a lot of our machine learning data. But the difference of, say, like you can see Postgres is one of our data or one of our data stores. The exact things that we store in Postgres versus Cassandra, I don't actually know the answer to that.
I can sort of answer that. I work at Coffee Meets Bagel also. Anything that needs to be atomic, transaction-based, we store in Postgres, and we're trying to move everything else to Cassandra. And then we use Redis for like data we want to cache, or data is going to be temporary. We use Elasticsearch for data that we need to search on.
I guess like, is there any particular reason why you choose something like Elasticsearch versus Cassandra?
Well, yeah, if we need to run complex searches on our data, if we need to run like filters on data with an unknown number of feature sets, we'll use Elasticsearch.
Okay. Other questions? Yes, sir.
Do you have any insights as to why we have to perform range repairs nightly?
Do we have the question was, do we have a reason to run the ranged repairs nightly?
Yes.
Yeah. Mainly it's because it's a huge pain. It's probably not 100% necessary to get directly to the. We could actually say only do that when we have an event, say we remove a node or add a node or something where we may actually need that repair. That might be a better way. The general idea was just that at a certain point, there's always something going on in the cluster. At least that was our thinking. That there would there's something we've had one node just randomly die due to AWS death syndrome. It just happens every once in a while randomly. There's always going to be something going on, so we just decided to just make it a rolling, regular thing. Sure.
A quick question. I thought I read somewhere recently that there's this configuration setting that you could put on a table called read repair chance, and that's supposed to amortize the time for repair. I don't know. I don't know what version of Cassandra that applies to specifically, but I don't know if that would help you.
Yeah. So the question or the statement was that there's a read repair chance configuration in Cassandra that basically, as I understand it, there's a certain percentage chance every time a bit of data is read that when the driver goes and gets quorum, or when Cassandra goes and gets quorum for that data, then that data is automatically kind of repaired in that, and that there is a setting for that, and that's not one that we've actually used yet, but we're aware of it, and it's in the near future. it's something that's on our radar. But yeah,
That may help. I don't know.
Yeah, definitely on the repair side of things.
I don't know anything about Cassandra really, but.
No, that's a good point. Yeah. Yes, sir.
Yeah, sorry, so maybe you mentioned this already. What's the size of the cluster, the data that you store in Cassandra?
Our typical cluster size, at least in our main cluster, is about 300 or 400 gigs, I think, or our typical node size. And then I think right now we're running 15-ish nodes. Don't quote me on that. So it's not a huge cluster by any means. Okay, question? Yes, sir. You were like way in the beginning. Okay.
About your consumers, like customers or internal application, is it mostly happens during the day at noon, like several time zones, or it's like across the world?
The question is when our customers see, basically when the traffic happens, basically, right? So yeah, it's exactly that. It's there's a big spike at noon and it trails off, and then with the next time zone where it's noon, a little bit further east, it hits again, trails off, hits again, and so it just depends on where you're at in the world, even. So.
when it's like midnight in San Francisco, is still the traffic from Europe or it's quiet?
Yeah, no, it's noontime in Europe. So yeah, there's.
How quiet is it outside the noontime? How quiet is it outside the noontime? Is it like?
It's not completely dead. The question was how quiet is it outside of noontime, and it's not totally quiet. It settles into a more just an evened out traffic pattern like you would expect to see most places. Any other questions? Yes, sir.
I'm just curious if you've tried using Docker with Cassandra.
The question is, have we used Docker with Cassandra? And the answer is no. We're using pretty good sized machines, and we've considered it, but we haven't seen what the upside of actually using Docker would be for us at this stage of the game. It's something I like Docker, and I've used it for a lot of things in the past, but I can't think of a really compelling reason for us to introduce that into our Cassandra stack.
You
Yes.
mentioned that for different user case requests, you have a different data center. Will that increase the number of nodes? Will that make it more expensive?
The question is, when we have moving our use cases into different data centers, won't that increase the number of nodes and therefore our cost? The answer is, in the short term, absolutely, because we have to spin up a whole new data center. Long term, the idea is that if we can reconfigure the same amount of actual resources that we have, unless we're just underutilized or under provisioned at some area. So right now, our main cluster or our main data center is the same size as it was, but the idea is get things split out and then shrink things down to a point where it actually matches. That's one of the really nice things about AWS is because you can actually do that without having to buy machines, which would be a little different, trickier. Yes, ma'am.
Yeah, so about the node tool repair. Netflix has open sourced a little project called Tickler. What basic? So did you try that? Have you heard?
Yeah, the question is Tinker, right?
Tickler, yeah.
Tickler. The question was Netflix has released a tool called Tickler that should kind of do that. The answer is that happened, I think, after we had already implemented this. So it's not impossible that we'll go back and check that out at some point. But yeah, right now what we have is kind of working. But yeah, that's a good point. Any other questions? No? Oh, one more.
What are your upstream applications? Like what applications read from Cassandra? Is there any machine learning pipeline or read?
Wait, ask again?
What are your upstream applications which read?
What are the upstream applications that stream from Cassandra?
That read from Cassandra.
That read from Cassandra, right. Okay, so the upstream applications, mostly Python-based. They're, if not all, Python-based. Yeah. So yeah, just our APIs mainly. APIs. We do have some, data exports for, business reporting and things like that as well. But mostly Python, if that's kind of where you're asking. Yeah. Okay. Any other questions? Okay. Awesome. Thanks.